today. So y'all just bear with me. Did I give y'all phone numbers?
Yeah.
Yes? Okay. Well, the phone number for MyLabs Plus is 800-677-6337. And what's happening is, I think on yours, Jonathan, and if you people that's having trouble, is that you've had a past account or something, and that password is not matching with the T number or the password that you're typing in. That's the only thing I can come up with. Because some students, like, who was that came up? What's your last name?
Kubu.
Say again?
Kubu.
Oh yeah, Miss Kubu. Miss Kubu came up here and did it in 30 seconds. And that's what everybody should be able to do, unless you've had a previous account, previous password, and all that other stuff. Okay? Yes, ma'am.
I've never used the MyLabs Plus, and it wouldn't let me in. Like, never.
And you typed in your username.
Yes, sir.
Okay, well then chances are you need to call the 1-800 number also. I have no idea. See, when they took this, there's two ways to enroll. Okay? One way is to use my math lab. And that is self-enrolled. Okay? And I give you, teacher gives you a course ID. Okay? Well, we used that back when I was using it and nobody else was using it. That's when I used it. Because I brought all this on the campus. All right? They shifted, the math department shifted to MyLabs Plus. Now the difference between MyLabs Plus and my math lab, there is no difference. They're the same engine. It's the same thing that you use. The difference between them is that Tri-County Tech enrolls you. It's a mass enrollment that goes with the roster of the classroom. Okay? In other words, they take the roster of the classroom and they dump it into my math lab and everybody is enrolled. You don't have to enroll yourself. Okay? You're already in there. All you got to do is type in your username and password, supposedly. But somewhere down the line, something got messed up. It could be a T number. They could have forgot to put your T number. When it dumped over, it lost your T and the T number, and you're typing in a T, and it's not matching. Anything that doesn't match is going to cause a problem. And that's why some of you are having problems. The others are having problems because of a password issue. And then there's some, like Miss Kubu, that just goes right in. Okay? So, just be patient. That's why I'm also not jumping on y'all to do homework. I usually give y'all about a week to get on to MyLabs Plus. Okay? Any questions on that? If by Monday, if you've tried and tried and tried, then come and see me and I'll call them myself. Okay? But don't no hammies, okay? Don't spaz. Are we near a test? No. Have I given any homework yet? Not really. Told you to read. Okay, so you're not in a position to start spazzing. Question. Everybody good? Okay. So don't spaz. What we're going to do today is go through the unit of the reading that I told you that mostly is reading. So let me go ahead and pull up the ebook and we'll go ahead and look at that. what I usually do here is I usually tell students what to highlight and what to write down. So if you have a book, follow along. If you don't have a book, then write the notes down in your notebook. Take me a minute to pull it up. Can't make them all the same. Bush's fault. And like I said, this is the first time I've even seen this book, so y'all just have to bear with me. We're going to do this together. What chapter is it? 1? Is it chapter 1 we start in?
Yes.
Okay. Is it all sections? 1.1 through what? I heard 1.1.
1.2.
And it just does 1.1 and 1.2? Okay. Well, we'll do that. 1.1. And no matter what statistics you take, the first couple of chapters are going to be reading because there's a lot of terminology and all that good stuff. So you just have to read and write down the problems and write down the... So let's start with statistic. Write that down or write down page number 3, the yellow box. Statistic has a double meaning. So it says the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. Okay, that's pretty self-explanatory. Collecting data, analyzing, and calculating. Collecting data, calculating, and analyzing. That's what you're doing. Let's go ahead and talk about statistics. Statistics is made up of 2 things. A sample and a population. The sample is usually the smaller of the 2. And the population is usually the larger. Now, there's 2 important things in our lifetime. Time and what? Money. 2 important things, time and money. It takes too much time and too much money to survey a large group. So what do? We survey a sample and try to predict the large group by the sample. That's what we do. So the goal is to use sample data to predict population. And this saves time and money. Okay, so if I want to see how many students at Tri-County Tech are in the Marlboro Club, then the population would be Tri-County Tech. But I don't want to survey everybody at Tri-County Tech, so the sample would be maybe the Anderson campus at Tri-County Tech. And I would see how many people's in the Marlboro Club at the Anderson campus and use that data to predict how many people's in the Marlboro Club at Tri-County Tech with all campuses. Same thing with some of your polls that you have with politics. Some of your political polls are just done in 5 or 6 states, in a few states. And they predict the population, which would be what? The United States. So that's basically what statistics is. Now, in statistics, statistics is another word that means 2 different things. In statistics, you're going to be using symbols and formulas, and one of the 2 main symbols is the mean and the standard deviation. The mean is depicted by X bar, and the standard deviation is depicted by S. Now these 2 symbols are called statistics. It has a double meaning. And remember, statistics goes with sample. The S in statistics, try it again, goes with the S in sample. In the population, it's called, the same 2 are called parameters. The mean is depicted by the Greek symbol mu. And the standard deviation is depicted by sigma. Actually, that looks like theta, so I better add a little. There we go. Parameters are Greek symbols. Statistics are alphabetic. Now, why do you need to know this? Well, besides knowing which is what in statistics class, if you're ever in a presentation or a report given by somebody and you see a sigma, then you know it's the population. If you see a mu, you know it's the population. If you see an S, you know it's the sample. And if you see X bar, you know it's the sample. So it's a little bit of terminology, so you won't make yourself look ignorant in a presentation or a report, or if you ask a question, you'll know they put an S up there saying you're doing the research on the sample, but what about the population? And you know what you're talking about because it's an S instead of a mu, or a sigma instead of a whatever. So it's a little bit of knowledge for you to carry into a meeting or not to mention knowing what's the difference in statistics class. Okay? So that's a little bit of rundown of statistics to go along with your definition of statistics. I like to do that with some of the stuff. I go into it a little bit more in depth. Try to discourage you and make you fail. All right. Always the discourager. There we go. There's the population, and you need to make a note. Number 5. The entire group to be studied is called the population. An individual, I don't think I have to explain to y'all what an individual is. I don't want to insult your intelligence. And the sample is a subset of the population, which I've already told you that. And there is the definition of statistic. So this book is kind of falling in line with the other book. A statistic is a numerical summary of a sample. Descriptive statistics consist of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. Inferential statistics, and you need to know the difference between the two. Inferential uses methods that take a result from a sample, extend it to the population, and measure the reliability. That will be when we get in chapters 6 and 7. The inferentials will be later on. And there's your parameter. Is a numerical summary of a population, whether it be a mean, a standard deviation, a variation, whatever you find in a population is going to be called a parameter. And they should be telling you what a statistic is next, but I don't know if they do that or not. Okay, qualitative and quantitative variables. Everybody's heard the saying, quality, not what? Quantity. Well, that's basically what this is. Qualitative data is hair color, flip-flops, shoes, eye color. Those are your qualitative data. That has to do with non-numbers. Your quantitative data is your average weight, age, height. Anything having to do with numbers is your quantitative data. Quantitative data. And your qualitative is anything having to do with non-numbers. Who drives a white car? Who drives a car versus a truck? That's qualitative data. Okay. Average miles each student is from the Anderson campus. That would be quantitative data because it's numbers. I don't want you to spend an hour trying to figure out the difference between them. That's it. It's just a simple definition. Numbers, non-numbers. Anything that I cover, anything that I go over, as chances are it's going to be on the test. If you see me skip something, then what does that mean? It's not that important. Discrete or continuous? Let's talk about this. This is the number one. This is one of the easiest questions on my test, and people miss it. And it's not because I don't cover it. It's because I do. It's just people don't. I don't know what they do. I really don't. So I don't want you to write the definition. Don't write it yet, because I'm going to give you a Hubertism to remember. Okay. Now in school, you were given two different types of numbers. You were given rational numbers, and you were given irrational. And probably to this day, you don't know what they mean, because some people don't know how to explain it. Just like some people don't know how to explain how to read a tape measure. All right? A rational number are the following numbers. No, I don't want to use that one. Okay, what do those numbers have in common? Well, I was doing good until I put a whole number up there, wasn't I? Because then you were going to say fractions. Well, I was doing good until I put the decimal up there. So, what do all of them have in common? Anybody want to take a stab at it? Where did you learn that from? Usually people don't answer it. Thank you. They're definite. Thank you, Jonathan. I'm not used to somebody actually answering it. You must have had a pretty good teacher. Definite. Meaning that you know what the next digit is. What do you mean, Hubert? Well, what's 4 over 2? 2. Is there any doubt in your mind what the next digit is? No, it's 0. It's 2.0. There's no question. How about 2/3? What's the next digit? 6. Do you know that without a shadow of a doubt? Yes. Because if you do the actual division, you see that it's 66666. Okay? 5. 5 over 1 is 5. It's definite. What's the next digit here? 3. You know it because it's repeating. You know that digit is very definitive. Okay? Well, what's irrational? Well, irrational. Somebody take your calculator out. And I'm going to put 3 numbers up here. Well, a symbol and 2 numbers. And those of you that have a calculator, don't forget Wabbit.emu. If you want to download a do-jigger on your phone, if you got an Android, go to Wabbit.emu. Wabbit. Not rabbit, Wabbit. All right, tell me what pi is. Give me, okay, one person, please.
3.141592654.
Okay, somebody take the square root of 2. Tell me what it is.
1.41422356.
5 what? 5, 6? 2. And 7. Square root of 7.
2.645751311.
Okay, somebody tell me what those next digits are. Might want to put a $100 bill on them? Why? Because there's no what? There's no pattern. Sorry. There's no pattern. You cannot tell what the next digit is. And if you can't tell what the next digit is, it's irrational. Now, isn't that pretty easy? Not predictable. No pattern. Not definitive. Hubert, you were talking about continuous and you were talking about discrete. Well, guess what this is? This is discrete. And this is continuous. Let me give you an example. Let's say that I bring in a big box and I put it right here. And in this box I have tape measures. I have tape measures with digital readouts. I have the cloth tape measures. I have the metal tape measures. And I even have the old carpenter's tape measure that you fold up. You ever seen one of those? You fold up into little increments of a foot. They're old. Anyway, they're wooden. And I have about 20 or 30 in a box. And I tell each one of y'all, everybody see that fire hydrant down there? That fire hydrant right there. Okay, it's a fire hydrant. There's nothing special about it. Okay, I tell everybody down to grab whatever instrument you want to measure with and go down there and measure that fire hydrant from the bottom to the top. How many different readings will I get? 30. Why? Well, half of you can't read a tape measure. Okay? And 2.5 feet, 2 5/8 foot, you'll say 2.5 feet. You don't know how to read a tape measure. So half of you are going round wrong because you don't know how to read a tape measure. Some of you are just going to go from the top of the mulch to the top of the fire hydrant. Some of you are going to go down there and take your hands and scrape away at the bottom of the mulch and find the bottom of the what? Fire hydrant. And 2 or 3 of you are going to be too lazy to go down there and just stay up here. Okay? So, I'm going to have what? Am I going to have readings that I can depend on or not readings that I can depend on? Everybody's going to read something different. How about measuring how much milk a cow gives? If you pour it into one, somebody pours it into one, they read it different. Somebody pours it into the other. They're going to read it different. Anything having to do with what? Measuring. Anything having to do with measuring is going to be continuous. Now, I told you that. I told every one of you that. And there's a question on the test that says, what is the height of a tree? And y'all put discrete. I don't know why. Well, if measuring, I want you to think of real-life application. If measuring is real-life application, what is the only other type of numbers that we have in real life? There's measuring, and then there's what? Some of you people in retail that run a cash register, what do you do to your cash register at the end of the day?
You count it down.
What?
You count it down.
There's the word. What? Counting. If measuring is continuous, what is counting? Y'all are so smart. Anything you count is discrete. So if I have counting eggs on the test, is that discrete or continuous? Measuring a fire hydrant. Measuring a tree. Measuring weights of students. But I don't know what y'all do on a test. Y'all get that one wrong every time. Okay, let's go over the things that we measure. Some of the things. Length. Height. What else? Weight. About age. Well, for some people, age is continuous, because a lot of women have 29th birthday and that's all they have. Okay, but guys, our birthdays are discrete. Some guys are going, I don't understand. Shut up. What about volume? Volume? Is that measured?
Yes.
Yep. Please don't miss that question on the test. It's a simple question. How about donuts? Count them. Okay? Count donuts. Count eggs. You count the number of years you've been born. Okay? That is a test question. That's 2 or 3 test questions on the test because I like to give people points. Hopefully now you know the difference between rational and irrational. And you feel good about yourself. Right? Now you can use their definition. Continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any two values. I like the Huberdism better. The number of heads obtained after flipping a coin 5 times. Continuous or discrete? The number of cars that arrive at McDonald's, continuous or discrete? Ding! The distance. Ding! Distance. Continuous. You don't even have to read it. Distance is continuous. And you feel good about yourself. So you don't have to put smokestacks on your truck. Next. I'm looking to see if there's anything important there. Make sure you know these definitions. Not a big deal, just make sure you know the difference between them. I try and stay away from them on tests, but nominal. Remember that nominal is ranked or specific order. Does not have a specific order. Ordinal, remember ordinal means order. Ordinal. That's order. So I like to think of a race. First, second, third, fourth. Ordinal. Interval. A value of 0 does not mean the absence of the quantity. Temperature. Okay, that would be a good temperature. And ratio, a value of 0 means the absence of the quantity. I'm trying to think of an example of that. Money. If you have $0 in the bank, what does that mean? Broke ass. Broke. Okay? Dang old overdraft may help you a little bit, but you ain't got no money. So 0 does mean, and that's what they're asking you here. I'm not a big, I want you to know it just, I tell you why I want you to know it. You need to know it maybe for another statistics class, maybe where you transfer. That's the only reason you need to know these. I'm not going to use them in here that much. And that's 1.1. It says we go to 1.2 also in the syllabus. That means I want to interact with the class. That means y'all need to answer me. Somebody get the syllabus out. We go all the way through 1.5. Okay. All right, this is a